Okay, let's take a look at a couple of things that we need to factor. We also need to talk about the difference between what it means to factor and to solve an equation. So if we're going to factor something that has three terms, the first thing I do is I look and I see, do I have any common factor? I don't in this case. These two have r's. These are divisible by 5's, but that one isn't. So I don't have a common factor in all the terms. I have three terms. I think this one is quadratic. It's got a squared term, a regular term with just one variable, and then another term without any variable. So this one's quadratic. I'm going to use the quadratic formula. So I'm going to use A is 1, B is -10, and C is 25. And I'm going to use that in the quadratic formula. Remember, you can use the Pop Goes the Weasel song to remember this. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And you're using a, b, and c here. And I'm going to substitute those into my formula. The discriminant underneath the radical is 100 minus 100, so that's where I'm getting the 0. And I'm going to have it open its mouth and spit out some answers. So I'm going to go over the top first. 10 plus 0 is 10 over 2, which is 5. 10 minus 0 is also 10, which is over 2, so that's 5. So I'm getting 5 twice. So if I'm asked for factors, and remember my variable was r, then my factors are r minus 5, because it's always the variable minus the solution that you get here. So it's r minus 5 and r minus 5. And this can also be written as r minus 5, the quantity squared. So here, notice that if I have my inside and outside terms of FOIL, -5r, -5r, that makes up my -10r from back up here. A -5 times a -5 gives me that positive 25. So I've figured out what my factors are, and I'm checking it. So if I want to solve the equation, if I want to solve it, then my r is 5. These are solutions. So the answers that I get from the quadratic formula are my solutions. You can also think of them as roots, zeros, solutions. And on a graph, they would be seen as x-intercepts. So if I want to solve something like this where they're already factored, I can use the zero product property. That means that if I have something times something and it's equal to 0, then one of these somethings, one of these quantities, had to be 0. So I'm going to set each of the quantities equal to 0 and solve. When I do that with each, I end up with -3/7 and 3/4. And those are my two elements in my solution set. Here I have another one that's quadratic. It doesn't have any terms in common. It has three terms: a squared term, one that's not squared but has a variable, and then this term has no variable at all. Again, I'm running it through the quadratic formula, and when I do that, I get my two answers, 8 and -3. These are solutions. Remember, coming out of the quadratic formula, you find roots, zeros, solutions, and on a graph they would be x-intercepts. What are the factors of this trinomial that's here? What are the factors? If I want to make the factors, I do the variable minus each value. So that changes, when I make the factors, it changes the sign. And notice then that I get -8b plus 3b is -5b. And -8 times 3 is -24. Factors versus solutions. Sometimes when you're on the test, you'll get those confused and you're like, do they want me to write the factors out with the variable in it, or are they asking for the value only? the solution. Factors are fat, so these are wider than just the skinny solution. Okay, so a solution is the answer to an equation. These are the values that if I sub back into my equation, it would make the equation true. Here's another one down here. One thing you have to watch out for is if you're going to use the zero product property or you're going to use the quadratic formula, you need to always make sure that you have a 0 on one side, just like we did up there. This doesn't have a 0 on one side, so I'm subtracting this over and subtracting this over. So I'm just going to move those terms to the other side by either adding or subtracting, whatever I need to do, to get a 0 there. Now I've got my A, B, and C, and you can see that I've run it through the quadratic formula. The values that come out of the quadratic formula form the numbers that should be in my solution set, the elements. And then if I'm asked for factors, then I could do the opposite of those. So I would have S, because S is my variable, not X, S minus 7, so I'm changing the sign on that value. Now, this was a fraction. If I were to put the 2/3 and say just S plus 2/3, then I would only have an S here and an S, and I wouldn't have 3s squared. So this 3 is going to swing out in front, and then I've got a -2 that I'm thinking of where I'll write the S plus 2. So I can go ahead and do that quadratic factoring. You can also guess and check these. It doesn't matter which method you use. I like the quadratic factoring. But if you have a fraction, remember to put that 3 out in front. The bottom of the fraction goes out in front, because otherwise you won't get that 3 with your S squared. Then here are some cubes and squares patterns. You can do the difference of cubes and you can do the sum of cubes, but you can only do the difference of squares. When you're doing a squares pattern, it has to be subtraction, otherwise you can't do it. So down here I've got p squared plus 4. That addition with squares says that it's not factorable, so this is prime. Then if I have a squares pattern, here's some squares. If I have m squared minus 16, think of this as something squared minus something squared. So this is m squared minus 4 squared. Now, a squares pattern says binomial times binomial. So I'm going to cover up these squares here. And what I have is m minus 4. That forms my first binomial. The second binomial changes the sign from minus to plus. Then I wanted to talk about the cubes patterns. Those are sometimes a little more confusing, and there's two different types of those. There's addition or subtraction. So up here, I've got k cubed minus w cubed. So I've got something cubed minus something cubed. For a cubes pattern, you'll have a binomial and a trinomial, a 2-parter and a 3-parter. So I'll take the k minus w here, because if I cover up the 3's, what I have left is just the k minus w. That forms my binomial that comes first. Then I take the k and square it, put it first. Take the last one, the w, and square it and put it last. This is always addition in front of the last term, always. It doesn't matter if this is minus or plus, that is always addition, always. In the middle, it's the opposite sign of here, so I had a negative, that's why that's a plus, and then take k times w, k times w. Let's go down and look at this one. I've got x cubed minus 64. That's x cubed minus 4 cubed. And if you don't know what the cube root of 64 is, you can use your machine, you can use your calculator, and you may have to do, I'm not sure how you'll have to do it with your machine. You might look and see if you have, you'll either do the 3 and then the x root of it. So this is saying the cube root of the 125 to get a 5. Or if you have 125, sometimes they do x root and then you say the 3 after it. But either way, you would get a 5 for the cube root of 125. And here you would do the cube root of 64 and you would get a 4. So I have something cubed minus something cubed. I'm set up to just cover those 3's and take what's there as my binomial, x minus 4. Now I'm going to take the x and square it, take the 4 and square it, put it at the end. This is always addition, always. In the middle, it's the opposite sign, and this times this. Up here I have one more cubes pattern, 125 plus p cubed. That's 5 cubed plus p cubed. So I'm going to cover my cubes up. So what I have for my binomial is 5 plus p. Take this one and square it, put it first. Take this one and square it, put it at the end. This is always addition, always. In the middle, use the opposite sign and multiply those two together. I have another one down here at the bottom. So y cubed minus 8 is y cubed minus 2 cubed. This is y minus 2. Take this one and square it. Take this one and square it, put it at the end. This is always addition, always. In the middle, use the opposite sign and this times this. The last problem here is 8m cubed plus 27p cubed. Let's make this into something cubed plus something cubed. And remember, you cannot do an addition of squares, but you can do an addition of cubes. You can do both types of cubes, both add and subtract, but on squares you can only do subtraction. So this is addition, but it's cubed, so we can do it. Take this and rewrite it. That's 2m to the third power. 27p cubed is 3p, all of that to the third power. It'll be a binomial and a trinomial. I'm going to take away these 3's, and what's left is 2m plus 3p. That's what I write as my binomial. I take the first term and square it. I take the second term and square it and put it at the end. This is always addition, always. In the middle, it's the opposite sign, and multiply these two together to get 6mp. I hope this helps.